Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Listen up, hands down, eyes on the camera.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Mary Lou.
And I'm Chuck. Our phone tutors are here waiting for your calls. If you need help with your math homework, give us a call here in Bakersfield at 636-4357. You can call toll-free from outlying areas in San Luis Obispo at 1-866-636-6284. You can send us your questions via email at dothemath@kern.org. You can watch the show online, dothemathonline.net, and look for us on social media with Facebook, Instagram, Twitter, and YouTube.
All right. You know, I had a student, they emailed us a lot of questions.
Oh,
so we're going to do a couple of those through the email. And I responded, just watch the program today and tomorrow, and then you can pull up the program anytime you like on Facebook or YouTube. And that way students, when they see a problem, they can view it anytime they want. Just before we get started, I just want to check with Logan and those guys. Are we going to go back to Stonecreek real quick to see the intro with those guys? We going to do that real quick? We want to do that? We'll do that a little bit later on. All right, so we do have April out at Stonecreek Junior High School, so we're going to be doing some problems with those guys. But first, let's take a look at today's Math in the News. All right, today's Math in the News. I was just looking around the internet the other day and I found this article about the human calculator. Have you heard of this character?
No.
All right. Nor had I until that point, all right? So this guy's name is Scott Flansburgh, and he is known as the human calculator. So I'm like, all right, let's see how the human calculator functions here.
Okay.
So he would be given a series of numbers, and he would add them quickly, faster than a calculator can
Right.
input them, right? Fine, a lot of people can do that. Then was multiplying numbers, so 348 times 79. He'd have it out before, take that product, multiply it by another number, right? So he's just rapid fire with all
I've
these
seen
numbers.
those guys. It's amazing.
Can divide 3 digits by 2 digits and come up with the answer with the remainders and everything, and just remarkable watching somebody be able to do that. He travels the country trying to show students other ways of doing math problems, most of it mentally.
Right.
Okay, so Chuck, since you're on the end, if you could, go over to the board and on the blank side, on the right side,
Okay.
Write down a 3-digit number.
A 3-digit number, like 347.
There you go, and put another one underneath it,
Another 3-digit,
please.
152. How's that?
And let's do one more.
Oh, really? 3. How's that?
And just draw a line underneath and put an addition symbol next to it. So what he was doing is showing students that the way that they're traditionally taught is they would go 7 plus 2 is 9 plus 3 is 12. Put the 2, carry the 1.
Right.
Right? And he was saying that this is the way most people are taught how to add, but they're not getting everything they could because
Right.
you're not learning place value and other things, learning the value of what you're adding.
You're learning just a technique for doing them without understanding what you're actually
Right, so
doing.
he was
Right.
saying, instead of doing it that way, just start from left to right. So we have 300 plus 100 plus 700 is 1100.
So that's 10 and, okay.
So we have 1100 in our heads,
Okay.
right? We're just doing this all mentally.
Oh, okay.
1100 plus 40 is 1140. 1140 plus 50 is 1190. 1190 plus 80 is now 1270, right? So we have 1270 plus 7, 1277, 1279, 1282.
See, when you started doing that, I was using the community property because I'm going to the 7 and 3 real quick.
Right, so you could do that,
Yes.
get the
So
10 together.
Group
Yes.
things
But
and get the 7 and the 3.
by doing that, he was saying that students can learn some of the other properties using
Yes.
I mean, all sorts of things that you can do, putting the 7 and 3 together to get it to 10. Learning that it's 300 plus 100 plus 700,
Right.
not 3 plus 1 plus 7 and then carry the 1 or whatever number you're carrying.
Right, and carrying is just carrying without realizing you're changing
What your
place
the
value.
value, right.
and- right.
So that was with the addition. The next thing that he was talking about is how you can take any number, it doesn't matter what it is, all right? And this one we use the calculator for. Mary Lou, give me a well, let's go with 2 digits. It's a little shorter that way.
Okay, 62. 62.
All right, so we're going to put 62, all right? And then we're going to subtract the value of the sum of those digits. It will always come out to 9, no matter what number you start with. If you subtract the value of the sum of those digits, you will always end up with 9. So 62 is 6 and 2 is 8.
Is
So
8.
from that, we're going to subtract 8. We have 54. Now we had 5 and 4. We're going to subtract the value of the sum of those, which is 9. So we're going to subtract 9, and we have 45. Well, we have another 9. You guys see where this is going?
Yes.
You know this is a multiple of 9, so it's always going to come down to be 9. So for the sake of doing it for the kids at home that are like, all right, I kind of got what you're doing, but let's keep on going through this. So we're going to subtract 9, which is 4 plus 5. We have 36. Well, we take 36 and we add 3 plus 6 and we have 9. So we subtract 9. We have 27. 2 and 7 is 9, so we subtract another 9. 1 and 8 is 9. Subtract another 9. And you can see that we are now left with 9. Okay,
Subtract, yep.
subtract 9. Then, so any number, if you subtract the sum of those digits from that original number, will always come down to 9.
Right.
That's,
Right, I mean, yeah.
Okay.
So it's just one of those things that he's trying to get students to learn. Like, listen, it's just one of those things. It doesn't teach you how to subtract in a different way or anything like that, but just realizing. And the way he realized that, he was on a golf course with Alice Cooper.
Alice Cooper?
The Alice Cooper, the rock musician. Quite a golfer, by the way. Short guy. Met him before. Loves golf. Pretty good at it. But they were talking about his song, I'm 18. And that made him think, all right, well, the 1 and the 8, there's a lot of things you can do with 9s in math. We all know a lot of these tricks
Right.
and
Yeah.
different things you can do. But that was one thing he was like, all right, take 18, take the sum of those, 1 and 8, 9, subtract, well, if we take any number, take the sum of the digits, subtract it, you're always going to end up with 9. So it was just something that he found. So that is today's Math in the News, the human calculator, and things that he was able to do. Anyway, 636-4357 is the phone number. We do have phone tutors available until 5:30. As a reminder, every time you phone in to do the math and we do one of your math problems on air, your name is automatically entered. And that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. If you're in San Luis Obispo County, might be hard to come over and see the Condors, but you never know. You might be in town. You can go see the Condors, schedule whatever game you want. However, if you call from the Central Coast, we'll automatically give you free ice cream to Doc Bernstein's Ice Cream Lab. So
still wait to
Nice.
go there.
that's right. We're going to go to the phones right now and see ya. How are you today?
I'm good.
And you're a student at Buena Vista, correct? All right. And you're in 6th grade.
Yes.
All right. Why don't you go ahead and tell us the math problem that you're working on?
I need to have a total of 13 using the 4 numbers 5, 8, 12, and 6.
All right. Let me help Chuck get this out of
Get
here
this out
quick.
of the way.
So we just need to erase all of our addition there.
Gotcha. Okay.
So you have 4 numbers, 5, 6, 8, and 12.
5, 6, 8, and 12. Okay. And I'm sorry, what is it that you need to do?
I need to get a total of 13 using those 4 numbers.
So you can use any mathematical symbols and operations you'd like,
Yes.
but you need to get those 4 numbers equal to 13.
Yeah.
So we can add, subtract, multiply, and divide? Are there
And use anything like square root symbol,
Oh.
decimals, percent, anything you want, but those are the numbers that have to be used.
Yes.
All right. So have you worked on this? Have you gotten close to 13? Or do you have any ideas what you might want to do with this?
I've had 12, 14, and 15, but not 13.
Oh,
So why don't you explain how you've gotten to one of those other ones
yeah,
so we can
let's see
kind
how
of see your
close you get.
process.
You said you got 12. Let's see what you did to get 12.
That was earlier today. I already erased my work.
Okay, so give me one that you've done, just to see how you've started this problem.
I tried subtracting 12 from 6.
12
and
plus 6.
Then adding 8, then 5, but it didn't work.
Okay, so 12 plus 6 we know is 18, right? So
No,
you added?
I did 6 minus 12.
Oh, okay, so
So
you
she's going to end up with a negative number.
Oh, you got a negative number? You want 6 minus 12 or 12 minus 6?
6 minus 12.
Okay, so if we do 6 minus 12, let me get this here. So if we do 6 minus 12, that's going to be negative 6, is that right?
Mm-hmm.
And then you said you added
I
8?
added 8.
Added 8, so that's going to give us 2, isn't it?
Mm-hmm.
And so let's see, to get 13, if I multiply by 5, I guess we could get 10, couldn't we?
Mm-hmm.
So we got 10 that way. So let's see what we can do to get 12, huh?
We're trying to get 13.
I mean, to get 13. You said you got 12, didn't you? All right, so let's see. What do we have to do? We need 12. We need 13. So we've got a 2. How about, let's see, we've got some division we can do. We got 12 divided by 6. That's a 2, isn't it?
Uh-huh.
Okay. And we've got 5, look at that. 5 plus 8 is 13, isn't it?
Uh-huh.
That's nice. If we could just somehow get rid of that 12 and 6, that would be nice, wouldn't it?
I already tried that, but I couldn't find anything.
Couldn't try it? Let's see. Well, let's try 12 divided by 6. That's 2, isn't it?
Mm-hmm.
So 12. So now what can we do with that 8 and the 5? If I have a 2, what can I do with the 5 and the 8?
Add them?
Okay, so we could add 5. That gives me 10, doesn't it? Excuse me, 7. I don't know where I got 10 out of that. That gives me 7. And then if I add 8 to that, well, you said you got 15, didn't you?
Yeah.
Now, see, I know that this is a tricky problem to work on.
Mm-hmm.
And we've done this in the past, which is why I remember this. We've done it a year or two ago. And Mary Lou is frantically working on this as well over here, trying to see if she can
Yes.
come up with a way also. Now, I saw
Yeah.
you came up with 12 because you went a 60 minus
Yes.
48,
Yeah.
doing some multiplying of some numbers over there.
Yeah.
See, what I'm going to do is I'm going to provide you with a clue here. And I want to see if you guys can figure it out. Keep in mind that you know that you can use any operation, add, subtract, multiply, and divide. All right? Let me put it forth. You're only going to add. All right? You're only going to add, and remember that you can use mathematical symbols. Okay? Because if I remember correctly in the directions, it says that you can use decimal points and things like that.
Oh, okay.
So, what I want you to do is I don't want you to let these guys do the problem for you. I want you to think and kind of guide them. Where would you possibly put decimal points and only add these numbers? Okay? So go ahead and talk through this with these guys.
Oh, I think I see it. Because, well, let's start. See it? Let's start with 5 and 6.
Okay.
What happens if you add 5 and 6?
When you add them, you get 11.
11. Okay, how much more do we need?
2.
We only need 2. We want to make 2 out of 8 and 12, but Mike said that we can put decimal points in there, can't we?
Uh-huh.
So can you make 8 and 12 equal to 2 by putting in some decimals? Well, what happens if we added 8 and 12?
If we add them, we get 20.
8 plus 12 is 20, but you don't want 20, do you?
No.
What do we want?
We want 2.
How do you make this a 2?
Oh, put a decimal after the 2.
So we want the decimal point right there, right? Is that right?
Mhm.
So we don't want to add 8 and 12, do you?
No.
What do you want to add instead of 8 and 12?
5 and 6.
No, let's take, we've got the 8 and the 12. Those are the numbers we've got, right? The digits. But somehow we have to make 8 and 12 add up to 2.0.
Mhm.
How are you going to make 8 and 12 add up to 2.0?
Why don't you go ahead and show her 1 if she doesn't get this one?
So we said we can use decimal points, right?
Uh-huh.
So how many decimal places did you have in your answer? How many decimal places in your answer?
None.
We just had 1, right? 2.0, one decimal place, right?
Mhm.
What happened to my screen?
Well, it got covered up somehow,
here.
so we'll.
There you go.
Okay.
Yep.
So we've got just 1 decimal place here. So how many decimal places do we want up here?
I'm not watching right now, so
Oh, you don't see this?
I don't see it.
Okay, so 2.0 is the answer we want. So instead of 8 and 12, let's put decimal places in the 8 and the 12. Let's put a decimal place in the 8. So instead of 8, let's write it as 0.8. And instead of 12, let's write it as 1.2.
1.2.
So what happens when you add 0.8 plus 1.2?
You get 2.
You get 2.0, don't you?
Uh-huh.
So putting in those decimal points is going to give us 5 plus 6 plus 0.8 plus 0.2, and guess what that equals?
13.
That's going to equal 13. How's that?
That makes sense?
Uh-huh.
Okay, so using the decimal points helped out right there, and that's what a lot of students forget, is
Yeah.
that using any mathematical symbols will help with that as well. You still online with us, Sia?
Uh-huh.
All right, well, for having such a great problem and stumping these guys for a couple of moments, we're going to send you away with a meal courtesy of our friends at Johnny Rocket, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. I know there are other students probably working on that problem.
Yeah.
That is the only time we will do it live today, so hopefully you were watching. And maybe later on we'll make reference to that problem. So if you need to see that problem, you can look at today's program later on YouTube or Facebook and see, oh, that's how you do the problem. We'll go ahead and do it like that. Anyway, let's get to one of the emails that somebody sent in. I think this was Kirsten sent this in, working on some expressions. So Mary Lou, here we go.
Okay.
4, open parentheses, 7x minus 2y plus 3, close parentheses, minus 5, open parentheses, 6x plus 5y minus 1, close parentheses, simplify please.
Oh my goodness, we got a couple different variables going here. But the first thing we need to do is we obviously, according to PEMDAS, take care of our parentheses. And I'm seeing distributive property because we have a number that is outside. Again, it's saying, hey, I need 4 groups of 7x, I need 4 groups of negative 2y, and I need 4 groups of 3. So let's go ahead and take care of those first by doing our distributive, and we're going to distribute that 4 to everything on the inside. So 4 times 7x is going to give us a 28x, and then 4 times our negative 2y is going to give us our negative 8y, and 4 times our 3 again gives us our plus 12. And then we need to do the same thing over here, but a lot of times students don't pay attention to that negative. That minus sign right there in front of the 5, that means it's negative. And so we need to pay attention to that. So we need to look at that as a negative 5 and distribute that negative 5 accordingly to everything on the inside. So we have our negative 5 times our 6x, which again is a negative, and we show negative as a minus sign, giving us a negative 30x. And then our negative 5 times our 5y is going to give us, again, another negative 24x. 5y. And then lastly, a negative times a negative, giving us our positive 5. The next step is we want to combine our like terms. So I'm going to use the commutative property to rewrite this, making sure that all my variables are together. So I'm going to put the x's together first. And when I do this, it's really important that we are taking whatever operation is in the front of it, so minus the 30x. And then I'm going to combine all of my y's. So again, I have a negative 8y. And then over here we have a negative 25y. And I save my constant terms for the end. And again, those are my numbers by themselves with no variables. So I have a 12 plus a 5, adding that on the end. And now I can see this and I can quickly combine my terms. So I have my x's first. And again, I have a 28 minus a 30, giving me a negative 2x. And then here we have a negative 8y and a negative 25y. And remember, I'm grouping all those negatives together. So we have 25 and 8, which is going to give us a negative 33y. And then lastly, I'm combining my constant terms, 12 plus 5, which is a positive 17. So again, making sure, usually we want them in order, alphabetical order. We always leave our constant term for the very end. Why? Because this is saying multiplication. We have to multiply this, we have to multiply this, and then we know that we're going to add whatever is left over. And there we go, our negative 2x minus 33y plus 17.
All right, nicely done on that. Thank you very much. Hopefully that helps out Kirsten and some of the other students working on expressions right now. 636-4357 is that phone number. We do have phone tutors available until 5:30. I know that we're going to be going out to Stonecreek Junior High School in a little while. Good. April, one of our tutors, is out there. She's got some excited kids ready to do some math out there, and we will be visiting them in a little while. But first, let's do one more expression. This one has a little bit of a different twist on it. Instead of the two different variables, this one's going to be a little different.
Okay.
Here we go. We have 6x minus x, and then open parentheses, 4x plus 1. And if we could simplify that.
Okay. Again, looking at this, we have distributive property. Whenever we have a variable, again, next to parentheses, that's distributive property. A lot of times students are going to make the mistake, and the first thing they're going to do is they're going to want to simplify this. They're going to look at it and go, oh, 6x minus 1x. That's 5x. And then I'm going to take the 5x and distribute it. No, 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 no. Remember that this is saying, hey, I'm going to be multiplying this number to whatever is inside there. So that's really important. That's what we need to take care of first. And again, we call this our invisible 1, okay, because of our identity property. So this is really saying negative 1x. So we need to take this and distribute it first before we can take care of that x. So again, we're going to bring this down, and we're going to have a negative 4x, and then we're going to have a negative x. A lot of kids want to do 1, and that is fine. Again, 1x is the same as x. Now I can bring this 6x down.
And before you keep going, after you bring the 6x down, let's remind the students that negative 1 times 4 is negative 4, but we have an x times an x.
Right.
Which will make it
x
squared. There you go.
Yes.
That's the reason I wanted to do this problem for those students.
And that snuck away from me there. So yeah, because we have two x's, so we need to make sure it's x squared, because we're really saying x times x, which again is x squared. And now to go ahead and combine our like terms, the first thing I'm going to do is I'm going to take this x squared, because there's no other x squares. That's the only one. So we have our negative 4x squared. And then now I can go ahead and combine these, and I now have 6x minus our 1x, which is going to give us a positive 5x. And again, don't let that sneak away from you like I did. Again, if we're saying an x times an x, we got to have that x squared there. And there you go.
All right, nicely done. Thank you for that. We do have phone tutors available until 5:30. We'll be back with more right after this. Today we're in San Luis Obispo. We're at Laguna Middle School, home of the Lancers, and today we're here to... Well, today we're at Laguna Middle School in San Luis Obispo. We've got 7th grade student Landis with us. And how are you today?
Really, really good.
You're really good? You
Really
look
good.
like you're ready to compare some numbers.
I am.
All right. Let's go with this. How about, would you like to compare fractions or decimals?
Fractions.
Fractions. Excellent. So what we'll do is we'll go right here, we'll go right here. Now, the symbols that you're going to have an option to put in between here, if you're comparing numbers, do you know what those symbols are called?
Yes.
What are they?
Greater than, less than, equal to.
Right. And why don't you go ahead and put the 3 symbols over there and tell us as you write them what they are.
Okay. This is less than, right?
Are you guessing or you don't?
I know it. This is greater than, and this is equal to.
Okay.
Maybe.
This is what?
Less than?
Greater than.
Greater than.
So if you want to, you can just put a little G right there if you want.
Oh, yeah. This is less, this is greater.
Right, so this is greater than, right? So I would
Yes.
say 4 is greater than 2, right?
Okay, yeah.
So this is less than. And this is equal, right? Do you remember when you were in younger grades, did they ever have you guys with this, like pretending it was like some sort of an animal eating
Yeah.
the larger number, right? Okay, so you remember it's always open to the greater number. One way to remember it. Okay, so we're going to compare 2 fractions, all right? You are going to provide all the numbers. I will put them where I want,
Okay.
okay? So I don't care what number you give me. Nothing over 2 digits. We won't make it too hard for you.
83.
83?
42. Okay. 23. Can you do that? Wait, okay.
You can't put them anywhere. I put them. You only say them. That was the deal, right?
Yeah.
Okay.
73.
All right. You've got some nice numbers to work with.
Okay.
So how are you going to go about this problem, first of all? What are you trying to do first?
You have to figure out which one is greater, if they're equal, or yeah.
Okay.
So first you have to make the denominator same, right?
Well, you can do that. There's also a way that we can do this a little bit easier, because to find the common denominator between 83 and 73, you're probably just going to have to multiply those together,
Yes.
which is going to be a very large number, all right? What we could also do is we could estimate this, okay? So one thing I would suggest is maybe estimating. 23 is about what?
20?
It's about 20, right? And 83 is about
80.
80. Now, if we had 20 over 80, what would that simplify to, do you know?
2 over 8?
Well, it would be 2 over 8, and if you wanted to simplify it even more, what would that be?
1 over 4?
Okay, so why don't you just put 1 over 4 under here? So we know that that estimates to be 1/4.
Yeah.
You agree with that? Okay, why don't you estimate this?
Okay, so this changes to 40 to 70.
Okay,
Then I want to do even more. It goes to 4 over 7.
perfect. Now, there's some students going to be watching and they're going, well, how did you get to 4 and 7? Because we could see that you divided each of these by 20 and then you went down. What did you do here?
I just got rid of the 0.
Right, just get rid of the 0 and you have 4 over 7. So why don't you go ahead and write 4 over 7 down here as your estimate. Now, if we have 1/4, okay, is that more or less than half?
It's less than half.
It's less than half. If we have 4 out of 7, because 4 isn't going to go evenly into 7, so 4 would be about half of what?
7. It's going to be more then.
It's going to be more than half, right? Because what is half of 7? Do you know offhand?
3?
3
and a half.
3 and a half, exactly. So this is less than half,
Yes.
and that is,
More than half.
so what symbol could we put in there? So which one of these fractions? Right. So let's go back to the original problem and put the symbol up here. And then if you would read that problem for us.
Okay, 23 over 83 is less than 42 over 73.
There you go. And you did that using estimation, so we didn't have to go ahead and multiply and get those big numbers, right? Landis, nicely done. Perfect. And once again, a big thanks to all of the students and staff out of Laguna Middle School. We had a wonderful time over there. I don't think there's ever been a time we didn't when we went over to
Right.
the Central Coast visiting the schools and then all of the activities we're able to do. Just great folks over there to work with as well. As a matter of fact, if you give us a call from the Central Coast, toll free 1-866-636-6284, you'll be getting some free Doc Bernstein's ice cream over
Nice.
there. And I know that soon we will have the flavor inspired by Do the Math released
Right, oh,
over
good.
there.
They're working on that, huh?
Oh, we came up with a recipe and
right.
wait until you see this thing. It's going to be, you know what? We should see if we can have some brought over. Maybe we'll send Mac or somebody over to the coast.
Yes.
And,
That'd be fun.
hey, go over there and get us some ice cream, bring it on air one day, and we'll all partake in that. Anyway, we'll go to the phones right now. Tweety, how are you today?
Good.
Do me a favor and go to your TV set and turn the volume down on the TV set.
Okay.
And once you do that, we'll be all ready to work on your problem. You can go ahead and read it as soon as you're ready.
Okay. 844 divided by 4.
844 divided by 4. And is it in the division box? Or is it written out?
Yes. It's in the division box.
Okay. Can you listen to me over the phone and not the TV? Can you turn your TV set down? There's a delay, and so if we talk on the phone, then I'll hear you.
Are you still with us?
Yes.
Okay. So just turn the volume down on whatever you're watching us on and listen over the phone. It'll make things a lot easier.
Okay.
Okay? So the question is, what is the problem? Is it 844? Is it a division symbol?
It's in the division symbol.
So now you have to put it in the box, right?
Yes.
So it's important now when we do this, remember what goes inside the division box. What goes inside the house? It's given 844 divided by 4, but what goes inside and what goes out in front? So it's important that we remember that the 4 is what we're dividing by, okay?
Okay.
So I'm going to put the 4 out in front, and we're going to put the 844 inside. Okay? So you notice that the order changes when I actually do the division, the house, because the division sign tells me what the divisor is, and the divisor has to go in front, doesn't it? Okay? So let's go ahead and do the division. 4 goes into 8 how many times?
2.
2 times. Very nicely, when I multiply 2 times 4, it's exactly 8, and we get no remainder, do we? So what's our next step?
You bring down your 4.
So I'm going to bring down this 4, and I'm going to divide 4 into 4, which again is very nice because it goes in there evenly, right? 1 time. And 1 times 4 is 4. And again, I get no remainder. So now I bring down
The other 4.
the other 4, and 4 goes into 4, again evenly, very nicely, 1 time, and 1 times 4 is 4, and we get a remainder down there of 0, don't we? So since I have a remainder of 0, I have no other answer up here, and it looks like our answer is going to be the nice whole number 211, isn't it?
Are you still online with us, Tweety?
Yes.
All right. How can you verify? How can you check to make sure that that's the correct answer? Do you have an idea on how to do that?
Not really.
All right. Well, Chuck will show you how to make sure that that is the correct answer.
So you said let's divide 4 into 844 to get 211. Okay, now we check because we know that 4 times whatever number is up here should be 844. So let's see if that works out. We're going to take our answer, the quotient, we're going to multiply it by 4, which is our divisor, And what we should get is that number that was inside, that's the dividend. And let's see what happens. 4 times 211 is 4, 4, and 4 times 2 is 8, and we do get that answer, so it checks that our answer is really 211.
All right, there you go. Now you've got a way that you can verify, make sure that that answer is correct. Thanks for that phone call, and your name is now entered into that drawing for the family 4-pack to go see the Bakersfield Condors. We went on Saturday night, because Friday night was opening night. We went on Saturday night, and you can tell the difference in the level of hockey.
Oh, yeah.
From the ECHL to the AHL
AHL.
now that they're playing right now. Only their second game, so I'm sure it wasn't as crisp as they would have liked it. They didn't win that night. But you can tell the difference in the level of hockey when you go out and see the Condors now. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now we've got a problem a 7th grade student was working on. Percent of change.
All right.
So we're going to go from 5,000 to 7,000.
Okay.
And we need to know what is the percent of increase from 5 to 7,000.
Okay, percent of change is that exactly that. We're trying to find what the percent is of the change from these numbers. And what we do is we have this formula where we first find what the difference is between these numbers divided by the original number. So taking this knowledge, we're going to find the difference between that. So we're going to think, what is 7,000 subtracted from 5,000? And we're going to divide that by the original, and the original number was 5,000. It's always the number we start with. We're going to divide that all by 5,000. So 7,000 minus 5,000 we know is going to be 2,000 over 5,000. Well, we got a lot of zeros there, and we could get rid of a lot of these zeros to make this a lot simpler. So we're really looking at 2 over 5. So 2 over 5, again, we need to find out the percent of this, and percent means per 100. I know that 5 can go into 100 20 times, so therefore I'm going to multiply both of these by 20, and I know that 2 times 20 is 40, and again percent is per 100, so this is 40 out of 100. As a decimal, it's going to be 40 hundredths, and as a percent, it's going to be 40%. But a lot of times we're dealing with increase and decrease, so we have to ask ourselves, are the numbers increasing or are the numbers decreasing? Well, going from 5,000 to 7,000, I've increased my numbers, so therefore my final answer would be a 40% increase between those numbers. And there we go.
All right, nicely done. Do remember we have phone tutors available until 5:30. And I know the students at Stonecreek Junior High have been working hard all day and even harder after school. So let's go out and see what they're working on with April.
Hi, we're back here live at Stonecreek Junior High, and I have Crystal here, and we are going to classify numbers. So Crystal, what does it mean to classify a number?
To give the number the name.
Give the number name. So we've got this box here. Is there anything we can do with it? Can you draw on there and show me what we can do to organize our thoughts?
Yeah.
So we're going to call the numbers by name. So what names should we give it? Should we call numbers that go over there?
Irrational.
Irrational. So do you know what irrational is? Irrational means
Like a repeating decimal. But like doesn't end.
never in decimal. Okay.
Irrational.
And then over here, what kind of numbers can we put over here?
Like whole numbers.
Whole numbers.
So
And whole numbers start at 0, right? So let's put the word whole in there. And then what else can we call numbers? They can also be called
integers.
integers. Okay, so another place for that, and let's call that what? Integers. And whole numbers and integers are also called what type of number? It's the opposite of irrational.
Rational.
Rational. And rational numbers and irrational numbers are what a part of what type of number system? What number system is it called?
Real number.
Real number system. So this is the real number system. So we've got these numbers over here. Let's change pen colors. We have to place these numbers and call it by a name, okay? So if we have the square root of 7, where does the square root of 7 fall in our diagram here?
Irrational.
It's irrational. And do you know why it's irrational?
It's like can't be multiplied by two numbers to get it.
So you can't multiply a number by itself. You can go ahead and write it there. You can't multiply a number by itself to get the square root of 7. And the square root of 7 is a never-ending decimal, right? That's about 2.78, something like that.
Yeah.
Okay, so we're done with this. What about, how do I say the number here?
0.8 or
8
8/10.
8/10. So 8/10 would be what type of number? Where would I put that on my diagram?
Rational.
It would be rational. And do you know why it would be rational?
Because it could go in a fraction form.
Because I can write it as a fraction. And do you know what type of decimal it is? Let's go ahead and put that 0 in front. Do you know what type of decimal that is? Is it terminating or repeating?
Terminating.
Terminating, because it stops and it can be written as a fraction, therefore it is rational. What about 4/5? Where does that belong?
Rational.
Rational, okay. Go ahead and write that under rational. What if the 4/5 was negative? So if I put a negative on it, is it still rational?
Yes.
Yes. Go ahead and put a negative on yours as well, okay? And what is that number?
Pi.
Pi. Where does it belong on our chart?
Irrational.
Irrational. And it is irrational because?
It's never ending.
Can you write it as a fraction?
No.
No, okay. So that goes under irrational. And last but certainly not least,
2.
2. Where would 2 fall?
In whole number.
Whole number? Okay, go ahead and write it there. So does 2 belong anywhere else? Where else can it be?
All numbers.
Okay, so 2 can be
Integers.
an integer. Write it there again. And 2 can be
A rational.
a rational number, yes. And every number on the board falls under what set of numbers?
Real number.
Real numbers. So all of them are real numbers. Okay, and so every single one of these numbers are part of the real number systems. Real numbers are rational numbers and irrational numbers. And we're going to head back to you, Mike.
Thank you for that, April. Nice to see all the students at Stonecreek Junior High working hard and enjoying the weather outside.
Oh, yes.
Nice day
Nice
out there.
day.
You know what? There are places where it would be so lovely outside, let's say. And I don't think it's exactly lovely outside, but they're in the shade. I can see that. But it's not raining, it's not snowing,
Right.
and there's not a lot of wind blowing everything around. So nice to see that they got everything kind of worked out at Stonecreek Junior High. 636-4357 is the phone number. We do have phone tutors available until 5:30. I know there are some students that are phoning in, and they want to know how to get 13 by using the 4 numbers 5, 6, 8, and 12. Well, we did that right at the very beginning of the program. We had a student phone in, and we were able to do that. So if you are looking at this and you're like, hey, I need to know how to get 5, 6, 8, and 12 equal to 13, at the end of the program, pull up today's program on YouTube or Facebook, and you'll be able to see at the beginning of the program how to get 13 by using 5, 6, 8, and 12. In the meantime, we're going to do a little multiplication right now.
Okay.
We're going to multiply a decimal by a mixed number.
Okay.
So 2.6
2.6,
times 3.5,
3 1/2.
and that's what you need to multiply.
All right, so since one of them is a decimal and one of them is a fraction, I guess I could either have my choice of putting my answer as a decimal or as a fraction. Do I have that choice, Mr. Kershaw?
Write it as a decimal, please.
Write it as a decimal. So let's go ahead and write this answer as a decimal. So instead of changing 2.6 to a fraction, I'm going to change 3 1/2 to a decimal. And very nicely, we know that 1/2, right, is 1 divided by 2. So if I needed to, I could change that to a decimal very easily. by dividing 2 into 1, add a decimal, because that's what I'm changing it to, and 2 goes into 10 5 times, and my decimal comes straight up. So I know that 1/2, not 3.12, but 3.5 is my decimal for 3.5. And so I get 2.6 times 3.5. I can do this multiplication problem pretty easily. Let's do it down here. I'm going to get 3.5 up on top and multiply that by 2.6. And let's see what we get. I'm going to do my multiplication with just the digits and ignore the decimals. So I'm going to get 6 times 5 is 30. Carry the 3. 6 times 3 is 18 and 3. That's 21. Now I go 2 times 5. That's 10. Carry the 1. 2 times 3 is 6, plus 1 is 7. So it looks like when I add this up, I get 0, 1, and 9. I need 1, 2 decimal places. So down here, I'm going to take my decimal over 1, 2 places. And it looks like my answer is going to be 9.1 for my answer to this problem.
All right, nicely done. Thank you for that. That way students can see you don't need just a whole number times a whole number. You can do decimals times mixed numbers, not just a fraction by fraction, things like that.
Right.
All right, nicely done. Well, you know what? We do have some more time. We're going to go out to Stonecreek Junior High, and I believe that Grimm is getting ready to do a little bit of work with April.
Hi, we're back here live at Stonecreek Junior High. I have Grimm here.
Hello.
And we are going to simplify some fractions. Grimm, are you ready?
Got it.
Okay.
Yeah.
So we've got 3/5 plus 7/10. And can I add straight across and get 10/15?
No, you cannot.
Okay, so tell me what to do. Like, how are we going to work
Okay,
this
so
out?
what you first want to do is you want to get a common denominator between the two. So an easy way to find the least common one is just to times both of them.
Okay.
And so 5 times 10, if we do that math, is 50. So,
Okay, so is that the smallest number that they have in common?
well, you can do that if you want to just get it easy, but
Okay.
then you would have to do like simplifying in the end. An easier way to do it that I was taught today is just put down the multiples. So how to get to 5, it's 2. Oh, well, that one's already a common multiple. So then we also have
So let's
7
let's
tenths.
go over here. Let's write down the multiples of 5. So what's 5
Yes.
times 1?
So 5 times 1 is 5.
And then 5 times 2?
5 times 2, 10, 15, 20, 25, 30, and it
And
goes
then we'll
on.
stay right there. So then,
And then next
let's
we
do the
have-
first 5 multiples of 10.
Then we have 10, 20, 30, 40, 50. So then when we do this, it actually turns out that 10 is our least common multiple between
Okay,
the
so
two.
we've got 10.
And
And
10.
we're going to set up a new fraction here?
Yep.
Okay, so
And so it took us times 2 to get to 10 here. So now, and so what you do to the top, you have to do to the bottom. So what you did to the bottom, now you have to do to the top. So we're going to times by 2 again. That equals 6. So now we have 6 tenths plus 7 tenths. Now, what you want to do is you want to add the numerators because the denominators, they stay the same through. So that's still 10.
and if you could put an equals in there, you go.
And then 6 plus 7, as we all know, just regular 6 plus 6 is 12. Add 1 more, that's 13.
Good logic
But
there.
now we have a improper fraction.
Very nice.
So what we're going to do is we're going to see how many times 10 goes into 13. So it doesn't go into 1, so we're going to put a 0 there. That goes into 13 once, which
Great.
is 10, subtract 3. So our denominator is going to stay the same. So this is 1 and 1. This is 1 and
A remainder.
3 tenths.
And if you could put an equal sign there so that we know
Equals
it's
1 and 3
continual.
tenths.
Very good. And it looks like we've got that all simplified. And back to you, Mike.
Nicely done with those guys out there. Nice to see Grimm doing some work out there with the fractions and a lot of different things that the students in junior high are working on. What are some of the things that you guys are working on in class right now?
Actually, the expressions and equations.
Okay.
And a lot of fractions.
Which students get introduced to in 5th grade a lot. And I'm not sure if they get a lot of work with fractions in 4th grade or not, but 5th grade they get introduced to them because I know it's fractions, decimals, percents. They work a lot on those things. And then as you can let kids know, you're going to be doing this a long time from now, so the sooner you learn it, the easier thing is going to get as you keep on going. But you did say that you were working on expressions.
Yes.
And we've had you working on expressions today.
Yes.
So back to the board, let's work on
Okay.
some more expressions. Here's another one, and this one has a little bit of a twist with this one also.
Okay.
So 8, open parentheses, x plus 4, close parentheses, minus, open parentheses, x minus 5. Now the reason we have this one is because there's nothing outside of the parentheses and what the students need to do in order to make this a little easier on them.
Okay. Actually, this is something that I am working on with my students recently. The first thing is that we know we need to do distributive property here. Okay, so I'm going to do that first. If I look here, we're going to distribute it. We have our 8x plus our 32. Okay, so here we have that. Then we still, I'm going to bring this straight down, our subtract x minus 5. There's a couple different ways we could really look at this problem. This is what we have. We have 8x plus 32. That's what our total is. The minus is telling us from this total, we want to take away 1x, and we want to take away a negative 5 from that. That's what that is really saying. Okay, again, so we have this as a total. We're going to take away whatever we have here. There's another way to look at it, and that is distributive property. We can add that invisible 1 here because it's saying what is the opposite of 1x and what is the opposite of negative 5. So let's go ahead and use our distributive property to really look at this. So we have our negative 1 times 1x, which again is going to give us just a negative x. A lot of times students go 1 times 1 is 2. No, remember 1 times 1 is just 1. And then we have our negative 1 times our negative 5. Again, a negative times a negative is going to give us a positive 5. Now we're going to bring this down. We have our 8x plus our 32. And now we're ready to combine our like terms. But again, remember, when we're looking at this, again, this is our whole. We're taking away that from our whole. So we have our 8x minus our x plus our 32 plus our 5. Again, I'm combining my like terms so it's quick and easy for me to solve. So 8 minus our 1x gives us our 7x. And then we have 32 plus 5, which gives us a positive 37. And there we go. We've simplified that out.
Nicely done. Thank you for that. And the reason we wanted to do that one is because there was no number in front of that parentheses, and a lot of students would just go minus x minus 5.
Yes.
And that can get everything messed up from there for. All right. 636-4357 is the phone number. We do have phone tutors available until 5:30. If you're a student and you have not received one of these stickers that we're going to put up on the board right now, you need to call us. Let us know. We can send some stickers out to your school. If you're an instructor, a parent, you work someplace and you know somebody that would be able to use this information, all of the information that you need to know about Do the Math and what we offer, when we offer it, how to get a hold of us, all of the information that you need is on that sticker.
Yes.
We've sent them out to every single school in the county as far as if you have any grades between 4th and 8th, and then high schools have received information as well. So if your school is in Kern County and you have not received any of these materials, or you would like more, simply let us know. You can give us a call. You can email us, get a hold of us on Facebook. There's all sorts of ways you can get a hold of us. Just let us know that you need more stickers, binder dividers, cards, posters, whatever you'd like. We're more than welcome to send those out to you. Right now, speaking of sending out, we're going to send it back out to Stonecreek Junior High with April.
Hi, we're here live at Stone Creek, and I have Rosanna Natividad here. She is the ACES After School Mentor. Hi, Rosanna.
Hi.
Can you tell me a little bit about ACES?
Yes, ACES is funded through the After School Education and Safety Grant. In our district, ACES stands for All Children Excel in School. It's an after-school program that we offer to 2nd through 8th graders at certain locations in our district.
What happens in the ACES program? When is it held? What time?
It's held immediately after school until 6 p.m. and there are 4 components that we meet each day. So
Okay.
the kids are brought in, we take attendance, give them a snack, take them out for PE, have homework and tutoring, and then the last part of the day is an enrichment.
Okay, and so what type of enrichment activities are included in this program?
Well, here at the junior high, there's technology, there's sewing and cooking. At the elementary level, we do arts, we do science projects. We have Kern Schools Federal Credit Union that comes in and collaborates with us. They teach banking lessons, and then they take the kids out to their sites
Sounds
for
like
field
fun.
trips.
Very nice. So how is it easy to get in the program, or how does it work?
It's based first come, first serve. We are only at certain sites, so we have 10 elementaries and 3 junior highs.
In the Panama District?
In the Panama District,
Okay.
yes. And as far as enrollment, parents are required to come to a parent orientation, which we'll be having one on October 20th at Actus Junior High at 6 p.m.
So the orientation means that you're still accepting enrollment now?
Yes, at certain sites we are. We do have waiting lists at some sites as well.
Okay.
But they can contact us at the district office and we can give them that information.
Perfect. So it was so much fun here at Stonecreek today. I'm glad you guys invited us to do the math. And back to you, Mike.
All right, thank you for that. Nice to see the ACES after-school program out there. I know there are a lot of schools that have programs like that. Wonderful things that they do out there. The ACES program, AVID, I know that they have a lot of different schools going on. I know that there are a lot of schools that have Boys and Girls Club sites there at the schools, and we are big fans of the Boys and Girls Club because I know they're big fans of Do the Math. And I know that when the executive director, Zane, came in, he just loved the program, loves that the Boys and Girls Club has an opportunity to use Do the Math. And just as a matter of fact, the executive director for Kern County Boys and Girls Club last year was the National Executive Director of the Year for all of the Boys and Girls Clubs in all of the United States. So that's pretty cool that we've got that executive director right here in Kern County. Speaking of winners, let's find out another winner. Every time you phone in to do the math and we do one of your math problems on TV, your name is entered into a drawing, and that drawing every single day is for a family 4-pack to go see the Bakersfield Condors. And today, let's find out who the winner is.
The winner is Grim from Stonecreek.
Oh, there you go, one of
Jr.
our callers from
Nice.
Stonecreek Junior High. So congratulations to Grim. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, and Bakersfield City School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.